IT resiliency, manageability, and let's face it, some of what happened on July 19th, Blue Friday, with the CrowdStrike issue and how Intel vPro was able to help rectify that situation very quickly and efficiently. So right now you're seeing the agenda. We'll start with a quick introduction, baseline on our case study, dive in on what is Intel vPro. Oftentimes that's a name that people are familiar with, but they don't know what it means. We'll deep dive into two key feature sets, both AMT and Emma. We'll explain those in greater detail soon. Do two quick demonstrations. Unfortunately, I'm operating out of a hotel room in Austin right now, so they will be video. They will not be live. Finish up with some lessons learned and then questions and answers. So this is going to be a shorter talk because I want to make sure there's plenty of time to answer any questions that anybody on here may have. So without further ado, a little bit about myself. I own the large enterprise commercial client segment for the client commercial group inside Intel. And I'd be remiss if I didn't take a moment to do a special thanks to Hector Lorenz, Dan Brunton, Brian Wetland, and Jen Larson. They helped develop or provide a lot of the content on the technical and business aspects of this, make sure that what we're presenting is as accurate and as meaningful as possible. So vPro and AMT saved us. I'm going to let this sit here for a moment. This is feedback that Intel received shortly after July 19th. And this came from one of the largest home improvement stores in Australia. Now, this company, fortunately, was able to recover over 5,000 transaction points quickly and efficiently using the Intel vPro features, whereas there are some other customers or partners or companies, shall we say, that have made the news, and you've seen economic impacts from this mass outage ranging from millions to tens of millions to, in certain cases, hundreds of millions of dollars. And let's be honest, not every enterprise is able to absorb a hit like that. So it's incumbent upon us to understand what the problem was and the steps that we can take to not only fix the problem, but also prevent it from happening in the future. Now, as I earlier mentioned, the case study we're going to be using is Blue Friday. That was the CrowdStrike outage on July 19th. And something I want to be very clear with is that this is not an opportunity to dog on CrowdStrike. They are an excellent company. They're an excellent partner with Intel. We work together very deeply, and we've done just some fantastic work together. Accidents happen. It's not just CrowdStrike. It's Microsoft. It's Intel. It's McAfee. It's whomever else. If you haven't had an outage, you most likely will. And it doesn't have to be anyone's fault, but the worst part would be if we didn't learn from what happened and try to drive forward and improve our operations accordingly. So July 19th, 2024, CrowdStrike released a flawed update that forced a logic flaw and a blue screen of death across impacted PCs. Microsoft is estimating that it was roughly 8.5 million PCs impacted worldwide. Now, why was this such an impactful event? What made the CrowdStrike update so harmful? Well, as you can see on my very ultra-simplified graphic, it was due to where the update sat. It was a kernel update, so it sat right in between the hardware and the operating system, meaning that the end user was unable to boot Windows to be able to rectify the situation themselves. So what happened? Well, first, there was an immediate response. The good news was that CrowdStrike had a fix published within the first 79 minutes of the flawed release. But there was a problem. For those without Intel vPro and our AMT and Emma feature set, it was very labor intensive to fix. It was one person fixing one computer at a time. The manual remediation steps required that you had physical access to the device, and it resulted in a lot of costly engagement with IT. And we say costly truck rolls here, that's when IT has to go and physically drive to the end user and fix it. So not only is that costly, is it time consuming, is it impactful for your business, it also hits on the sustainability and raises carbon footprint as well. Now, contrast that with Intel vPro and Emma, or AMT and Emma. That's one person serving multiple systems at once, remotely. There's no physical access required. And then to put the little cherry on the top looking forward, the remediation steps that we used, and we'll be showing further on in this webinar, are soon to be automated to make it even easier and even simpler to recover from a mass outage, such as what we saw on the 19th. The bottom line is that Intel vPro customers with AMT and Emma reported being back online within hours. And we'll have a couple more anecdotes later on in the presentation talking about just how successful some of our partners were in this situation. So first question you're probably asking yourself is, how did Intel with vPro do it? But before we go to that, I want to cover what is Intel vPro. Like I said, it's one of those names that you've seen around, but you're unlikely to know the full extent, the depth and breadth of the vPro platform. So Intel vPro actually started out around 2006, 2007, and has grown into an umbrella name for a commercial platform that we believe is the absolute best solution for the enterprise user. It's based around 4 different pillars: productivity, security, stability, and manageability, with a 5th one that is rapidly becoming more popular, sustainability. This takes advantage of feature sets that have been within Intel vPro for a number of years, and we added on a couple additional IPs on top of that. Now, we're going to dive into each pillar a little bit just to explain what that really means, get beyond just the marketing terms. So first, for performance. Powerful silicon, that's sort of a given. With Intel vPro, you get the latest Intel architecture, but you also get hardware and software security and stability features. In fact, there's over 33 hardware-baked features on Intel vPro platforms that it takes advantage of. Second, there's enhanced connectivity. So with the Intel vPro, you have in-band and out-of-band connectivity over Intel Wi-Fi, Ethernet, Thunderbolt docks, and 5G. We'll get into what out-of-band really means in a few more slides. So what that means is that for connectivity, you have faster and more responsive optimized network access that ensures not only security and stability, but also performance for your enterprise users. Third, you have software optimizations, whether that's using the Intel Connectivity Performance Suite, IPS, or the Advanced Connection Manager. You have a deep roll of IPs that are dedicated to making sure that your connections are secure, that your workloads are prioritized, and that your end users have the best possible experience. Now, moving to security. This is another one of the main pillars of the Intel vPro. We're very proud to address security on a multi-layer approach. Starting with above the OS, we have our Intel threat detection technology that we have worked in development with many of the big names across the security industry. You can see them on the slide. We have our OS layer security. This is work that we have done in co-engineering efforts in conjunction with Microsoft, and we stand by the fact that Windows 11 Pro is the most comprehensive OS for security in the enterprise space. And then finally, we have below the OS. That's based around the Intel Silicon Security Engine, as well as various other things that we've done on the hardware side, including security partitioning, dedicated hardware, and firmware authentication. Now, for stability, this area is something that we have been emphasizing for a number of years, focusing around the what we call this Stable IT Platform Program, also known as SIP. Now, what SIP does is it provides an assurance to IT professionals that there will be no changes on the Intel platform or associated hardware for up to 15 months, really helping reduce those opportunities for issues going forward. Second, we focus on comprehensive validation. We have teams dedicated to validating all of the Intel hardware, software, and Intel vPro security and manageability use cases, including we have our own red teams that go and they try to break vPro. And as soon as they break something, we figure out how to fix it. We've been proactively searching out these stability and security issues for nearly 17 years now, again, resulting in what we believe is to be the most stable and secure platform out there for enterprise. Now, we support multiple OSs, so we support Windows 10 and Windows 11. And for those in the ITDM space, you understand that not everybody transitions at the same rate, and we want to be there to support the ITDM to transition as they need to. And that's something we're very proud to enable that span of coverage. And then finally, this is a number taken directly from Microsoft. We have over 99.7% Windows 11 Pro application compatibility. So if it's something that you run, your company runs, chances are it's going to work and work best on an Intel vPro system. So if you remember the pillars, that brings us to the fourth one, manageability. And this is where we're going to spend the majority of our time in this conversation. Now, Intel's manageability approach has multiple different feature sets, but the big three that we'll be discussing is first and foremost the active management technology. Now, active management technology, or AMT, allows for remote access to a PC, even if it's powered down, the OS doesn't work, or the user is not present. Now, I'm sure you can understand how that came in to be very important with the CrowdStrike issue. Next, we have our Intel Endpoint Management Assistant, or EMA. Now, EMA is a program that allows for scale, access, and operation of AMT. It's something that enables IT to manage Intel vPro systems at an enterprise level quickly and easily. Now, the great thing about EMA is it's either a standalone software or it is easily integrated into third-party applications, many of which I'm sure you're familiar with, such as Workspace ONE with Omnissa. Finally, there's cloud native management. That's something that we've worked into EMA, as well as we're pursuing a couple of new paths in the upcoming future that you'll be hearing about in the next couple of months that allows for software as a service management of Intel vPro enterprise PCs. Now, if we continue to look at what we considered modern manageability, there really is a solution stack. This is just diving in a little bit deeper from what we were just discussing. And it all begins with the Intel vPro platform. Again, Intel vPro is not just silicon, it's not just a name, it's silicon, it's connectivity, it's hardware, it's software. It is a vast, deep collection of IPs that provide the depth and breadth and a secure foundation for manageability inside the enterprise space. Now, on top of Intel vPro, we have our Intel AMT technology that derives from much of the hardware and software from the vPro platform, as we previously mentioned, and then EMA sits on top, along with partner integration, if that's the route we take. So when you look at the actual device management, Intel has taken what's really a two-pronged approach. We see the first is in-band manageability for all Intel-based PCs. This is something where your system is sitting on your network, it's in your building, it's easily accessible, and it's something that Intel makes it easy, but quite frankly, there are also other OS manageability programs out there that can do much the same thing. Where we believe the future of manageability is, I'm getting a notice that my internet connection is unstable. So Jack, if you can let me know if I break in or out at some point, that'd be helpful. So the second prong to device management is what we call the out-of-band manageability for Intel vPro. And this is really what differentiates the vPro platform from, we believe, anything else that's on the market. This utilizes our Intel AMT technology to access the system where it's at, whether that's behind or outside of firewalls, whether that's remote, hybrid, what have you. It allows the ITDM to go in and update, modify, etc. systems easily and efficiently. And we'll be getting into more details from that. But bottom line is that we believe that the customer value provided by Intel vPro is significant because it really is what is necessary to keep PCs performing at their best. It provides an opportunity for optimal endpoint configuration, given that scale cloud-based approach to manageability. And it also encourages and increases the sustainability for the PC fleet. Now, something that is, again, becoming more and more important is it also provides an opportunity to increase the sustainability of the enterprise, something that is becoming very essential in Europe as well as many other geographies. And again, for this, we're going to just dive in a little bit deeper on what out-of-band manageability for Intel vPro means. So what is out-of-band management? Well, out-of-band management means that the management happens at the chipset and not at the OS level. So if you look at this graphic, you have your network down in the lower left. Your management traffic comes in from the network, and this is for a wired platform, by the way. The wireless is slightly different. We'll be getting to that in the next slide. But your management traffic comes in through your network interface and goes directly to the on-chip hardware-based Intel Converged Manageability and Security Engine, which is where the Intel Active Management technology is based. Now, from there, your manageability happens on the silicon, whereas the rest of the non-management traffic is passed to the OS. So you can see that if your OS isn't working, that doesn't really matter. Your manageability traffic is already being intercepted and processed at the silicon level. But what does that look like on wireless? So for wireless, it's a little bit different because it depends on whether your OS is on or off. Now on the left side of your screen, you see what happens when the OS is online. So your management traffic comes in through your network, hits your network or wireless network interface, will travel into the OS before splitting off and going back down into the Intel hardware-based management technology. Now, if your OS is offline, say there was a CrowdStrike outage that created a blue screen and nobody can get on their OSs, this is an opportunity for the network traffic to go into the wireless network interface and then engage directly with the hardware-based management that Intel has. From there, if there is the ability to push traffic up to the OS, you can do that, or you can do such things as restart or adjust BIOS from there. So this is a good transition. So what exactly is possible when you use Intel AMT? And let me call out that there are many different features. I don't think we have the time to go through all of them, so I picked a couple of the most important ones to cover today. First and foremost, it's hardware KVM. KVM stands for keyboard, video, mouse. What it does is it provides a hardware-based access point for a IT administrator to access a device just like they're sitting in front of the screen. So they can be anywhere in the world and they can have full access to boot your system, modify boots, modify programs, etc. We will have a video demonstration of this coming up in just a few slides. Next, it provides boot redirection. So if you think about the good old days when IT administrators used to wander the hallways with a USB stick in a pocket, and they would use that to reboot and fix systems with an IT load. Well, what this does is it allows that same process to happen, but without the physical access to the system. So your IT administrator can reboot anywhere in the world to a different temporary environment. Third, there's unattended power controls. Now, this has a lot of usefulness inside the enterprise space, but it also actually has a lot of usefulness outside where if a system is unattended, such as a video display or something like that. And what it means is that through AMT, the IT administrator has the ability to cycle power on and off the machine at will and wake it up for updates, etc. And finally, there's upgrade management. So there's two ways to look at upgrade management. First, it allows the IT administrator to upgrade your system. Say you're a hybrid worker and you finish work for the day, you shut your laptop, you go off, go to bed, and your IT administrator is able to access your system, turn it on, provide an update, make sure that the update goes through, turn off the system, you go back to work the next day, you never notice the change. Well, that's when things work right. What if an update doesn't work right? Like a CrowdStrike or a kernel update for your security software. Well, what this does is it gives the IT administrator the ability to go in below the OS and find those automatic update files and remove them from the system or roll back the system to a previous version of the software. Therefore, fixing any possible issues and getting everyone back up and running, honestly, before they even know there was an issue in the first place. Now, when you take AMT, remember, EMMA is the next level up. That allows for the scaling of AMT. This is one of those unique interfaces that allows for easy third-party integration. But beyond that, if you're looking at just pure Intel EMA, two of the main feature sets here are that there's beyond the firewall support. It allows easy scaling no matter where your systems are. And there's cloud-based manageability for simple click UI interfacing for your IT administrator. Now, you've heard me talk a lot about EMA and AMT. And as I mentioned earlier, I'm taking this call from a hotel room in Austin, so I can't exactly give you a live demonstration, but I did find some videos that can walk us through exactly how these systems work. This first one's a little long. It's about 5.5 minutes. I hope you'll bear with me, but it does a great job of graphically illustrating the power of AMT and EMA.
Let me show you the setup that we have prepared for this short demonstration. There are two computers. One of them is the device to be managed using Intel AMT. AMT has been previously activated on this device. In order to use AMT, we have also connected the device to the power cable, and we have set up a Wi-Fi connection, which is now within reach in this room. The Wi-Fi connection is not only set up on the actual device, but also configured on the Intel EMA server. Now I go to the Intel EMA web interface, and I see here the list of endpoints. The last one in the list is the one I want to manage, and I click on View. I can first see some information about this device as well as the status. It's currently powered off, but importantly here, the green indicator shows that the Sierra connection is established, and that's something I just mentioned in the presentation, this red connection in red color, which is the one that the PC, the AMT PC, sets up in order to make it possible to be managed using out-of-band manageability. Now, I go here to the hardware manageability tab, and I can see some information about the device, also some hardware information, which you will shortly see here. It's loading. But what I actually want to do is to use the remote desktop functionality. So I go to remote desktop, and as a power action, I use here the power up feature. So you see that the device is booting. Keep in mind that it usually takes longer to perform these operations when using AMT compared to the normal operations, because these operations are managed by the Intel AMT hardware, which is some extra hardware attached to the CPU. Now we have the desktop available here. You can see it, and in order to manage it, I first check the settings here and change it to the fastest one, and I press connect, and then a 6-digit numerical code will appear on the screen. It consists of randomly generated numbers, 136359. I enter that code in the EMA screen, and then you see that the screen of this AMT device appears on the EMA web interface. I could do now pretty much anything as if I were standing in front of this machine at another location. So let's see, I could modify or view the Windows registry using here this keyboard video mouse function, make some changes to it. I don't want to do that now, but instead I just wanted to show you one more thing, namely to boot the device into BIOS. So therefore, I disconnect this KVM session, and then this frame that was blinking in red and yellow, it has disappeared. And now I choose power actions and power command, reset to BIOS. So then you will shortly see that the device is shutting down and booting into BIOS. It's booting. Perfect. So once the device has booted into BIOS, I have to press the connect button here again to establish the KVM session. And again, you see that this yellow-red frame is blinking on the AMT device. That is, by the way, a feature that can also be deactivated depending on if it is a manned or unmanned PC. The same goes, of course, for the randomly generated code, because when it's an unmanned PC, it's not necessarily possible for someone to read it there and for the IT admin here to enter it. So now I have the BIOS, I'm using the keyboard video mouse function. I could now, for example, have a look at the boot sequence, add boot options, delete boot options, but pretty much anything that I could also do as if I were standing in front of this device at another location, I can perform. But now I choose the exit function. And then the device will normally boot into Windows. It does.
All right. So there you saw a brief demonstration of Emma working with AMT. And obviously that was a staged demonstration. So I'm sure a lot of you were asking just what would it look like if we're dealing with a specific issue that we had on Blue Friday? What would happen if it had the CrowdStrike flood update? So this next video we're about to watch addresses exactly that, but you'll notice that it doesn't use the traditional MO interface. It's actually one of those other integrations that we've been talking about. One of those great things about Emma is that it integrates easily into third-party solutions. Even though this third-party solution just happens to be another version of an Intel solution, more specifically designed for Internet of Things and endpoint management. So
let me show you the setup.
Let's go to this one.
Hey everyone, today we're going to take a look at how we can use something like Intel AMT to get into Windows recovery and solve some different issues. So for this example, we're going to take a look at the very popular CrowdStrike bug. I've already got a device connected up here. We can imagine this is our remote device, a point of sale, a digital sign sitting somewhere out there. And we'll go ahead and immediately start a remote KVM session to take a look at our device. So it looks like we have our blue screen here, our famous blue screen, and we're gonna go ahead and try and fix this. So I will reset the device, and we'll follow this device all the way through post and recovery because of the out-of-band capability, essentially allowing us to do this even though the operating system is not functional or up right now. So I'll interrupt the startup process real quick. And for me, I'm going to hit F11 to get into Windows recovery. Of course, this will be different depending on your OEM, whatever F key that might be, but we'll give this a second to load in. And it looks like it is coming up. So from here, I can come into troubleshoot and advanced options. If I had other problems or issues to fix, I can access things like Windows safe mode in here and still maintain connection and solve that. But for this particular fix, we'll come into command prompt, and I'm going to log into my user. If I had like a BitLocker key that I needed to provide, I could do that at the same time there. But it looks like we have access now, and I'll switch to my C drive and go to our problematic directory. There we go. So we are in CrowdStrike, and we'll just search real quick for the couple of corrupted files that need removing. So looks like these three guys are our main issue. So I will update my command real quick to delete them. Looks like it was successful, but we'll just double check real quick, make sure they're gone. Yep, it looks like it. So we will exit out of command prompt and see if our fix worked. So let's continue to our regular Windows boot up and try and follow this through. Of course, this was a very manual process. A lot of end users, of course, had to apply this themselves. So this provides a way to kind of take that burden off of them and do this remotely. Of course, there are next steps of how you could use other features, things like IDE redirect or serial over LAN, on how you could automate this process and apply this fix. But hopefully this gives a little bit of an idea of one possible way and solution that Intel AMT could be used to solve these issues. So it looks like we are up and running here. We'll just log in and make sure. And there we go. So back to business as usual, and this device can go back to being used for whatever it was, a digital sign, a point of sale, a kiosk, whatever it may be. So hopefully that gives a brief idea on something you could use Intel AMT for. Thanks for watching, and I'll see you next time.
So for those of you keeping track, that took less than 3 minutes and 30 seconds to recover that system. There was no requirement for an IT professional to ever leave their desk, and they were able to access remote systems literally anywhere in the world. Oh, let's go. So what happened? Again, we all have seen the news. We've seen that there are certain companies that feel like they were extra impacted by the CrowdStrike issue, and there are lawsuits going around. There's hundreds of millions of dollars at stake. Those are the ones that were unsuccessful. Now, if you look at the list on the right, the blue boxes that we have, we've called out a couple of the successful partners who have fully invested in the Intel vPro solution. They were using AMT. They had either EMA or a third-party solution as well. And obviously, we've had to redact names from these, but just from reading the list, you can see that there is a lot of value that was gained from this platform. My favorite one, and again, because I was actually flying on July 19th, luckily I was one of the last flights to not be impacted, but I knew people who spent days in the airports waiting for flights because their airlines had been impacted. But there was a major US airline that was able to recover over 4,500 systems because they used Intel vPro with EMA to identify and remediate through out-of-band management and using the KVM feature. Now, that particular airline, they ended up having less than 1% of their flights impacted. It worked out to canceling somewhere around 30 flights out of however many hundreds, if not thousands, they were running that day. And another big example for us, another very important example, is a leading US healthcare provider. They recovered 900 impacted devices quickly and utilizing EMA and AMT, keeping patient data secure, keeping literal lives, keeping people safe. We have a negative anecdote of a hospital that unfortunately was not using the latest in the Intel vPro and AMT and EMA, and they had IT administrators with USB boot drives walking into surgical centers to try to update their devices while there were patients who were currently being treated. And that's just not a good situation for anybody. So we're very proud of what we were able to do. We were very proud of the fact that our Intel vPro technology with AMT and EMA was able to help countless partners recover quickly, recover easily, and have minimal impact, not only on their business, but also on their lives and those around them. So let's talk a little bit about lessons learned. First and foremost, outages can and will happen. This is not an isolated incident. It's not all CrowdStrike's fault. It's something that has happened, will continue to happen going forward. And it's a question of making sure that we learn our lessons and that we prepare better so that the next time something like this happens, we're able to be those organizations that recover quickly and efficiently, not those organizations that make the news because they lost $500 million in a day. Second, successful enterprise management isn't just about global meltdowns, but it's also about simplifying IT workloads. So everything that we've talked about today with regards to a major outage, the CrowdStrike issue, also applies to just IT managing enterprise networks on a daily basis. You make it easier for them to do that. You'll make it easier for them to recover in crisis instances as well. Third, physical access to systems is becoming harder to achieve because hybrid and remote work is here to stay. And it's no longer practical to think that your IT administrator is going to be able to have physical access to a system and be able to use a boot drive to get a system back up and running. Fourth, so easy and secure out-of-band management is key to minimizing business disruptions, as well as boosting enterprise productivity. The CrowdStrike issue cost certain organizations, again, tens, hundreds of millions of dollars. And by preventing that, by enabling easy, efficient access and remediation opportunities, using a system like a vPro, the vPro platform can truly transform a business in a time of crisis. And then finally, we believe that Intel vPro provides the best solution for the commercial AI PC in the pillars of performance, security, stability, manageability, and sustainability, all of which we hit on today. Now, if you'd like to learn more about the vPro platform, please visit our website. Unfortunately, it's not the easiest link, but a quick Google on Intel vPro will take you right to it. And with that, that brings us to Q&A. I would like to say we've been joined by Dan Brunton, who is one of the technical experts behind Intel vPro Emma. And between the two of us, hopefully we can answer any questions that you all have.
Thank you, Scott. Yeah, Dan, I know there's a bunch of questions flying in, so if you just kind of want to take those, have some fun answering. I know there's a billion in both places.
Yeah, there's a few we've answered here in the chat already, and some that I've marked to answer live here specifically that have been kind of repetitive and questions I've commonly heard over the years of working with this. Just by a brief matter of introduction, since I haven't talked much yet, hi, I'm Dan Brunton. I work with Scott. My day job is acting as a software product manager. Intel Endpoint Management Assistant is one of those products that I manage. Help to work out what the new features are going to be, addressing defects as we see them, etc. So happy to be here today, taking part in this and answering questions. And with that, let's get to the questions. So we're here to do. So a common one that I see is around Wi-Fi. Question from our Michael here was, do you have documentation for how Wi-Fi auth works for AMT? How does it work if folks are at home? So this is one of the great things about the solution we have. I think helps it to stand out from others. And the way Wi-Fi works is two ways. We talked about AMT being separate from the OS. So because of that, AMT has its own network stack. So when you configure AMT and put together the profiles and dictate how it's going to work, one of the things you can do is specify specific Wi-Fi profiles. So if I'm setting up my office Wi-Fi for folks who are maybe working hybrid or coming on site, I can specify everything there, and that includes 802.1x security, so that AMT is able to authenticate properly with Radius. And then folks that are working from home, we also offer the ability to synchronize Wi-Fi profiles with the OS. So when AMT is configured, say somebody's working from home, you configure the system while they're working from home. It'll take the Wi-Fi profile they're using in Windows right now. Most likely they're not running 802.1x. It's going to be with pre-shared keys, and it'll synchronize what's in Windows into AMT. And then likewise, as new Wi-Fi networks are joined, it'll see that action and synchronize those profiles. So that way we can ensure that no matter where a person's working, be it in the office or from home, they can use Wi-Fi, and we still have that ability to remotely manage. Some caveats, of course, I'll point out, if it's a Wi-Fi network that has some type of captive portal where you need to accept terms and conditions, things like that can get in the way, to be honest. But for the most part, it works fairly smooth, especially when you're thinking about people working from home. We do have some good capabilities there. Moving on next, from Long, we have a question on, without labeling, how can we tell if a computer is equipped with Intel vPro or not? I've spent about 17 years answering this very question. The good answer, the one that make my friends in sales and marketing happy, is to talk about a new feature we have called Platform Brand Identity, which essentially digitizes that sticker. So starting with our Meteor Lake platform, so that's our current generation, and moving forward, there are ways that you can programmatically look that up. For legacy platforms before that, there's not an easy answer in how to look that up remotely. We always refer to vPro as a brand more so than a technology. However, when it comes to the capabilities we've been talking about today, Intel AMT, there are tools that Intel offers and processes that you can use to discover if a system has that management capability. And generally, if it's an Intel AMT system, it's probably vPro. not exclusively, because as Scott mentioned, we have a lot of solutions in the Internet of Things space that have AMT included, but aren't branded as vPro. But again, you can find the systems that have that management capability, through queries, through inventory, that kind of thing, remotely, so that you can figure out if you have that capability, which is probably the one that is going to be most of interest, given what's been going on lately. And a couple more you can answer here. And I'll look back through the thread again. From John, how can I get my security teams to trust Intel vPro and AMT with historical vulnerabilities? I don't have to read the whole thing. I think if most of you can see the question, there's, it's had problems. The answer I would give is, and maybe this is going to be a little snarky. It's not meant to be, but how do we trust Windows? How do we trust Mac OS? How do we trust anything out there? One way or another, most all the solutions out there around technology have had some type of major vulnerability that could be exploited locally or remotely to gain privileged access. Intel AMTs is no different. We strive to not have these issues, but they pop up. We're human like everyone else. So to that end, our official answer is, take a look at, Intel's security pledge. We've made a lot of changes internally in processes, as well as to how we talk about this, and take security very seriously. I can't give specific details on what we do because it's security, but it's something that we take extremely serious. And the one thing I would ask is, there's going to be challenges. There's always going to be vulnerabilities in all these types of solutions that we use. Something will be discovered, but hopefully the benefits of using this technology and what it brings to you outweighs the risks, just like anything else. You've got to do that kind of analysis for all types of tools we use for managing devices. So it's, ask that question. Do we see benefit in this? If we really do, hopefully that helps to alleviate concerns. And if there's questions on how Intel handles that, we've got a lot of great documentation on our site. And if you do have an Intel rep that you work with, they can also provide some additional information on how we handle that. But it's a tough question. I don't have a really easy answer other than we care a lot. We are doing our best to improve our processes day over day, and we believe that the value that the future offers outweighs the risks. Everything's got inherent risk.
Yeah, and to add on to what Dan is saying, we do have teams actively working to break vPro. And we proactively are able to find issues. A recent proactive push was in SMM technology. And that's something where over the last 10 years, Intel, before prodding from the industry, we found a weakness, and we've enacted, I believe it's around 10 to a dozen different IPs and technologies that go and patch these holes. Unfortunately, that's a conversation for an entirely different webinar, but it's just an example that we don't wait for somebody to find issues. We look for those issues ourselves. We have one of the industry-leading bug bounty programs. Generally think that we find about 80 to 90% of all issues before the silicon is ever issued. And we're continually working to improve, just like what Dan said with our security pledge.
And if I could switch into sales mode for just a moment here and do a little advertisement. To that end, we care about the transparent visibility of these types of issues. So we have a fairly new capability. It's a service that ISVs can use right now. We don't have this feature surfaced for IT practitioners this time, but we call it Intel Device Health. And it's a capability where you can go through and work with Intel to be able to get better insights to what's happening below the OS in terms of security. So firmware components, other components that may have vulnerabilities, we have a capability to help you identify those and ensure that they get updated. So to that end, going back to the question on, trustworthiness, I think that's an example of one of the areas that we've driven improvements on, so that you can go through, see exactly what vulnerabilities you may have at the lower level that you don't necessarily see with other security tools, and be able to address those. So that would be the kind of thing like, if there was a vulnerability we found in firmware for Intel AMT, we'd have the ability to call that out in a tool like that, so that you could get a patch in to address that. All right, so just skimming through the other questions here live real quick. And I'll try, I know there's a few popping up just in the chat as well. So I'm going to try and get to a few of those. But if it's something they really, really want an answer on, if you can use the Q&A tool, that makes it a little easier for us. But with that said, we're about through this queue here. So a couple other questions have popped in. Quick one, learned from long is LTE 4G support. We've experimented with it a little bit in the past for some use cases, but today it's Ethernet and Wi-Fi. Yeah, I can't say what the future holds. In my own analysis of it, I've looked at it, and it's, other than increasing the cost of the device, because now you have to have a radio. Some of the service costs are still a little high. So in the background, I'm still dreaming that we can make something like this possible, but I couldn't tell you when. So good answer, or good question though, sorry. And let's see, does Intel vPro still integrate with Dell Client Command Suite? Is there any documentation? The answer is yes. Yeah, we still do. As a matter of fact, DCIV is using Intel Emma in the background to actually handle the configuration of devices. It then makes its own direct calls to systems to manage them. But yeah, there is still a link there. I keep up with that team on a regular basis as the Emma product manager. And yeah, we just say, take a look at Dell's site or refer to them for any specific questions on it. But yeah, we still work with them on a regular basis. And let's see, go ahead.
Oh, I was just going to say there was a question on battery life in the chat, whether AMT can be accessed on battery. Now, as I understand it, the device does need to be plugged in. Is that correct?
Well, yeah. So with devices that are on battery, Intel AMT will run as long as the device is fully powered on, an S0 power state for those who keep track at the nerdy level, or in sleep. But if a device is, a laptop is unplugged and is in hibernate or powered down, Intel AMT does not run. That's for a couple of reasons. One, we don't want to drain the battery. If I'm getting ready to get on a plane and I charge my laptop the night before so I can work, I want to see a full battery there. And the other is because we can't attest to the state of the laptop and where it is. When I get done for work for the day, I'll often, take my laptop off the dock here, pop it in my bag, and it's not exactly the best thermal environment. So we don't want to turn a system on to say do maintenance at night when it's lid closed in a bag where it can't breathe and could overheat and have some negative effects. So that's the main reason why. But yeah, if a person's sitting at home in the backyard, working where the sun's shining just to get a little vitamin D in, yeah, you can still manage that device as long as it's got as long as it's powered on. Now, if it's powered off and plugged in, you're good to go. But yeah, on battery, we don't manage it in that state when it's powered down and unplugged. All right, tons of questions flowing, and this is awesome. And we're going to try and get to as many of them as we can. So from John, does Intel AMT and Emma support non-vPro enabled machines? So in general, you're not going to see Intel AMTs on non-vPro machines other than, say, some of the IoT devices we talked about. And there are some Xeon SKUs for single socket workstations that will have vPro support, or I'm sorry, AMT support, but not be branded vPro. More specifically, it's not a feature you would typically find on consumer devices. It's one that you'd have to explicitly go out and buy with the system itself. So you wouldn't, say, see a vPro system or an AMT enabled system in, Best Buy or Costco or a similar type of retailer. So yeah, you explicitly get when you purchase the system, you buy a vPro enabled SKU, and then all of our OEM partners typically talk about that on their websites. You'll see all of it listed there. Now for Emma support for non-vPro systems, yeah, Intel Emma has software level manageability in it too. That'll work as long as the OS is up and the device has a network connection. So you can use Intel Emma to manage essentially any Windows device. We don't do anything to block other manufacturers, other silicon vendors. You can use Emma to manage anything at a software level. Again, but that requires the OS to be up, requires the device to have a network connection. Whereas with Intel AMT, we can work around those limitations in the OS.
Dan, John in the chat asked, can we integrate Intel Emma into cloud platforms like Azure and Intune?
Yes. So Intel Emma is, it's kind of got a classic architecture. It's, a Windows app uses IIS to present the web UI front end and SQL Server on the back end. So any kind of cloud service provider that can host those type of environments can run it. I personally use a cloud environment for my Emma test environment that allows me to be able to do demos, show up to trade shows with just a couple of laptops in my bag and be able to do product demos. So yeah, it works very well in that case. So it's designed to be used on-prem if you want to keep it local, hybrid if you want to poke a hole in your firewall and allow traffic to get through, or run it in the cloud. That's one of the big benefits is you get to choose the best methodology for running this that works for you. Another question that's come up a couple times I've seen here is, how do I get help? So, I believe the initial question was, hey, do we have a team of professionals that we can call upon to do this stuff? Yes, you do. One, if you have an Intel account rep, you can work through getting support with them. And if you don't have a direct relationship with a member of our field team here at Intel, Intel customer support also provides great help when it comes to this stuff. And both of those teams have a line, a bat phone, if you will, back to myself and my team. So no matter kind of which point you come in to work with Intel, if you've got a question that one of these teams can't answer, it's going to get escalated up to the product management team that I sit on, and we have a ton of people here to help out. So yeah, and to that end too, we're trying hard to also make the software easier and easier with each release, so that those friction points go away, and hopefully you don't have to spend as much time on the phone with us to get this activated. Our goal is to make it as easy as possible. So yeah, we realize that it's not as easy as it can be. It's definitely easier than it was many years ago, for sure. We've dramatically cut back on the number of steps and the complexity of them, but it's something we strive to continue to make easier and easier as time goes on. So yeah, keep asking the question, keep us honest, and if you do need help, we do have support in place. I can't speak to what the future holds, but we're looking at what else we can do to help improve this. So there'll be more to come on that in the future when I can talk about it more.
Mm-hmm. And Dan, that actually goes to answer John's question in the chat as well. Tell us more about your upcoming cloud services. John, there's not much we can talk about at the moment, but there will be more in the future day.
I can speak quickly to what we offer today. Intel Emma has been around for about 5 years now, and has been our first foray into that kind of space. But it's cloud, but it's kind of roll your own cloud. You got to go through and set it up yourself. So to that end, Intel has released a new ISV focused cloud service that we have, that is Omnissa, formerly VMware Workspace ONE, is our first customer to go public with it. We are working with others, but of course can't speak to those interactions at this time. But we do offer a cloud service called Endpoint Cloud Services that encompasses capabilities we refer to as chip to cloud for manageability, as well as that other capability, Intel Device Health, or IDH, that I mentioned earlier, as another service within that cloud infrastructure. So we have, again, thinking about removing friction for our ISV partners, now are offering up a solution for them where they can work with Intel. We manage all the infrastructure needed to talk to AMT, to configure AMT, take that workload off of them so they can very quickly and easily integrate capabilities into their products that allow you to have that single pane of glass experience. And then, for ISVs that haven't, gone down that path yet, we do offer the 2 pane of glass experience, and that's where tools like Intel Emma come in, so you can still take advantage of these features, even if the ISVs that you choose to work with haven't integrated yet. All right, we got just a few minutes left here, Scott, so I don't know if we want to finish with some closing comments, or if we want to try and sneak in a couple other questions before we finish up.
I'd say we might have time for 1 or 2 more questions from the Q&A. I'm looking through the chat, and it looks like we've got just about everything addressed here. Do you have any Q&As left?
Yeah, we have a few here. Let's see. And this is what I think is fairly apropos for what we've been talking about here. So, Core asking, how does Intel handle BitLocker on boot partitions and password requirements to alter BIOS? vPro, and especially the remote control capability, is intended to give you the experience of sitting in front of that device just remotely. So to that end, because everything we have works independently in its own little enclave in the chipset, you get to see the system and interact with it live. So if I need to do BitLocker recovery, I can see the recovery ID, go look up the appropriate recovery key, type that in. If there's a BIOS password I need to get into BIOS to make a change, I can type it in. So it's not fully automated in that we have a magic button you can press that bypasses all those types of checks. They're there for a reason, because folks want to harden their environment. So that, yeah, you can see all that stuff as if you were sitting in front of the PC when you do a KVM remote control session, and are able to interact with it the same way. But as we look to the future of how we can automate more of this stuff, yeah, we're trying to figure out safe and secure ways that we can automate that, so that if you do have to respond to a large scale event again, that you can do it in the most efficient way. So that's something we're investigating more, some more to come. But the important message is you don't have to wait for that. You can still save a ton of time and effort, even if you have to manually touch the systems remotely. As we saw with some of our customers that were, and the success stories that Scott shared, folks would have multiple tabs open, working on multiple devices simultaneously. So you can still scale that out and recover from an event faster, even if some of the work is still manual. It's the fact that you can be manual on 5, 6, 7, 10 machines simultaneously, just kind of tab, working your way through.
Mm-hmm. Yeah. All right. Being conscious of everybody's time, it looks like we have 1 minute left. Just wanted to say thank you very much for allowing us to come in and speak to the user community. We really appreciate the opportunity to tell a little bit more of the Intel vPro story and how we can use this hardware software stack to help mitigate, prevent, etc., from major outages, but also just minor normal IT day-to-day life. If there's more information that you'd like, please feel free to reach out either to a field team representative if you're working directly with Intel, or I'll volunteer my email. I'm sure that my contact information will be included along with the video. If not, Jack, I'm sure we can work something out. And Dan, I won't volunteer you, but if there's questions I can't answer, I'll be sending them your way too. Also, quick thank you to Dan and to the members of the Dell field team who are online right now helping answer questions as well. So thank you. And with that, Jack, back to you.